Falcon 9.
Payload deployed, Commander.
It's Sunday, January 17th, and you're looking at a live shot at Falcon 9 at Vandenberg Air Force Base. Hello and welcome to our live webcast for the SpaceX launch of Jason-3. My name is Kate Tice, and I'm a process improvement engineer here at SpaceX, and I'm currently standing in front of our Mission Control Center located in company headquarters in Hawthorne, California. Today's mission is launching from Vandenberg Air Force Base, which you might hear us refer to as Vandy during the webcast. That's about 150 miles northwest of Los Angeles, and while the crowd is still growing here behind me, the bucket list for the majority of SpaceX is to watch a rocket launch in person, so most of us are up there off-base watching. Today, Falcon 9 is carrying Jason-3, a satellite that will be measuring global sea levels. This is a big science mission, and later on in the webcast, I'll fill you in on all the cool stuff Jason-3 will be doing once we deliver it to the appropriate orbit. Another exciting thing on the agenda today is the landing attempt of our first stage back on the autonomous spaceport drone ship. While all of SpaceX celebrated after the successful and history-making first stage landing back at Cape Canaveral, Florida just under a month ago, today's landing attempt will be slightly different in that we're making another attempt for our drone ship, which is currently about 200 miles downrange from Vandenberg. So we got a lot going on today. There is a number of different camera shots that we'll have live for you from all around SpaceX, as well as the Vandenberg Air Force Base itself, live shot from the rocket, and of course video from space and live video of our landing attempt. So you'll see everything that we've got. A lot going on, so let's get started.
So we are live just here on the outskirts of Vandenberg Air Force Base, 20 minutes away from the live launch of Jason-3 to space. My name is Brian Malstead, and I write automation software for SpaceX, so I'm very excited to get away from my keyboard and see this launch live. I'm up here with a contingent of many friends, colleagues, and family that have traveled from our headquarters in Hawthorne, just 3 hours south, to be up here for the live launch. And as Kate just mentioned, if you've never seen a live launch before, I would strongly recommend adding it to your bucket list. It is a very different experience in person than it is on your screen. The light hits you first, similar to a lightning and thunderstorm, because it travels faster than the speed of sound. After you have visual confirmation that the blaze has started, the roar of the engine reaches your ears just moments later. It's an intense experience, so we're all very excited. Now, the actual pad is in the distance, well beyond those trees, so we'll get to see a little spark travel up through this fog once we reach T-0. Now, Vandenberg is a big, sprawling facility. It's one of the largest Air Force bases in the United States. For reference, Falcon 9 is about 21 stories tall, and as you can see, you can't visually recognize that from here. So it's one of the biggest Air Force bases in the United States. It's a little bit windy, but that's totally fine for launch. Very different than our lightning that we experienced out at Cape Canaveral. It's a little bit foggy, but that poses no risk to launch. So it's a beautiful day. Let's launch this thing.
This is Tom Pradario from the Avionics department here at SpaceX. And as my fellow co-host just mentioned, we have a lot of very exciting stuff coming up for you on today's webcast. First and foremost, today's primary mission is to launch the Jason-3 satellite into a high polar orbit above the Earth. Jason-3 is a NASA and NOAA scientific satellite designed to measure global sea levels down to the centimeter level, which will allow scientists to better understand the Earth's climate patterns and how they're changing. We are extremely excited to be launching such an important science mission, and we'll go into more details about the Jason-3 spacecraft later on in the webcast. Now, today we're launching from Vandenberg Air Force Base, which is our West Coast launch site. For our typical low Earth orbit and geosynchronous orbit missions, we normally launch from our Cape Canaveral site on the coast of Florida. However, different launch sites have different advantages and disadvantages depending on what type of orbit you're trying to get to. Now, Jason-3 is headed to a polar orbit today, which is a fundamentally different type of orbit and much better suited by a south-facing launch from Vandenberg Air Force Base. Jason-3 is also riding on the last of this configuration of the Falcon 9, which is appropriate seeing as the first of this configuration also blasted off from this exact same launch pad back in September of 2013. The countdown process for this version of the Falcon 9 is a little bit different than our last flight, so you'll get to listen into the terminal count at T-minus 13 minutes coming up very soon. It's also good to note this is the last time you'll hear a T-minus 13 minute countdown poll for future launches. Last but not least, the fifth Falcon 9 first stage will also be attempting to land after separating from the second stage, just like our last mission. However, this time we'll be attempting to land on our autonomous spaceport drone ship rather than at a pad back at the launch site. This drone ship is the Just Read the Instructions, the very same drone ship that participated in our landing attempts in spring and summer of last year. Now, if the Falcon 9 sticks the landing today, it will be the very first successful landing of a rocket on an ocean platform ever. Coming later, we also have a 45-minute coast period between our stage separation and our satellite deployment. Now, our fellow co-host Lauren Lyons also got a chance to take a look at the Jason-3 satellite. Let's take a look at her video right now.
My name is Lauren Lyons. I'm the mission integrator for the Jason-3 mission, and I am standing here in the hangar at Vandenberg Air Force Base. And the reason it's empty is the rocket just rolled out this morning with the Jason-3 spacecraft on its nose. Jason-3 is the fourth in a series of the Jason missions. Jason-1 and Jason-2 are still on orbit, and Jason-3 is going to join them, and together they're going to work in concert to measure global ocean sea rise. Jason-3's radar altimeter is so sensitive that it can actually measure changes in sea height of 3.3 centimeters. And it's worked on in partnership with NASA, with CNES, which is the French space agency, with EUMETSAT, and the spacecraft was built by Thales Alenia Space. I've got more mission integrating to go do, but you guys enjoy launch. Go Falcon 9 and go Jason-3.
Good morning, Happy New Year, and welcome to the launch of the Jason-3 spacecraft. I'm John Federspiel, a lead mechanical engineer here. John Innsbrucker is currently at Vandenberg Air Force Base supporting today's mission, so instead I have been doing my best to keep up with the various voice loops, as well as keep in touch with our engineers at the launch site to provide you with some updates as we go along. Today we are targeting a T-0 time of 10:42 a.m. Pacific Standard Time, and this is actually the last flight of our previous configuration of the Falcon 9 launch vehicle. Now, the biggest change with today's Falcon 9 that affects our countdown is that we are not flying with densified propellants. Densified propellants are significantly colder than what we're loading today, so we try and minimize their load time, and that's what we did at the ORBCOMM-2 mission. For this mission, since we are not flying with densified propellants, we began loading those propellants in a little over 3 hours ago, and right now we are nearly full on the pad, just doing some final top-offs. Now, there is a minor issue that the prop team is working through, and we're going to know a little bit more later on as we get into the countdown in a few minutes. But at the moment, it looks like we are go to enter into the terminal count at the T-10 minute mark. Now, because that countdown sequence is a little different, the terminal count auto sequence begins at the T-10 minute mark, whereas on our ORBCOMM-2 mission, we began the terminal count auto sequence at the T-30 minute mark. To enter that terminal count auto sequence, our launch conductor pulls the team at the T-13 minute mark, so just coming up here shortly. Make sure you turn your speakers up in the next 45 seconds, because this is going to be the first and last time you're going to hear a readiness pull come on the air for a SpaceX webcast. Now, today we are taking the Jason-3 spacecraft to an orbit of nearly 800 miles away and going to go to a speed of over 17,000 miles per hour. We're going to do that in all just under 10 minutes for the initial orbit burn, and then an additional 45-minute coast to reach our final orbit, a polar orbit at 1,300 kilometers by 1,300 kilometers. The team at NASA have given us a go for today's mission, and they are also standing by ready for today's launch. So I'm going to go silent now since everything seems to be go to let you listen into that go, no-go readiness pull at this moment, and we'll be back for some more updates later on.
Attention on countdown 1. This is the LC. All stations, please give me your go, no-go for launch. VC. Go. GC. GC, go. GS. Prop. Props, go. AVI. AVI, go. Radiation. Rad, go. Flight software. GNC. GNC, go. Ground. Ground is go. RC.
RC, go.
Recovery. Recovery's go. FTS.
FTS, go.
OSM.
Ocean, go.
FISPO.
FISPO, go.
ROC.
ROC, go.
Mission Manager.
Mission Manager.
Go.
CE. Go. NLM. NLM is go. LD.
LD is go.
Still need GS and flight software.
GS flight software is go.
GS is go as well. Copy. LD, report go to initiate terminal count.
Go to initiate terminal count. We're working on closure of the MVAC pre-valve observation, but go.
All right, so we had confirmation from our launch director that our go, no, go poll is good. So let's talk a little bit about the details for the mission objective today. Like we said, we'll be delivering Jason-3 to a parking zone of about 820 miles. For those of us that haven't been to space, you can think of that as the distance from New York City to Atlanta. So while it's up there, it'll be conducting a number of measurements. This is a big science mission. For the next 3 to 5 years, Jason-3 will be our eye on sea levels. It'll measure global sea level once every 10 days. In fact, it'll be doing that with an accuracy less than 4 centimeters. So you can think of that as the distance of the short side of my phone. For something that's 800 miles away from us and to measure accurately less than that, that's pretty incredible. Increases in ocean levels because an increase in that ocean volume generally means that that area of water is warmer. Warmer waters take up more volume, causing ocean levels to rise. And while the only time you might think of looking for warm water is when you're looking for your next vacation spot, forecasters and scientists look for warm water to help predict things like tropical storms and hurricanes. Both of these things are intensified by warmer waters, so the data gathered by Jason-3 can actually be used to possibly save lives from space. Yay, science! Another element of weather that everyone likes to talk about, especially here in Southern California, is El Nino. El Nino is characterized by warmer waters in the Pacific Ocean. Therefore, they can be detected from space by Jason-3 because of that higher sea level. In fact, many of the images that you have seen of this year's El Nino have been taken by the Jason family of satellites that my fellow co-host Lauren Lyons mentioned a little bit earlier. Today's launch window will last for 30 seconds and no longer. If for some reason we're unable to launch today, our backup date is tomorrow, Monday, January 18th at 10:31 a.m. Pacific time. So be sure to stay tuned. And like I said before, we have live video. You can see that the crowd is gathering here behind me, and we're getting excited.
Back live just outside of Vandenberg Air Force Base. The energy in this field right now is palpable because we are just under 10 minutes away from sending that vehicle through the fog to space. A quick moment to discuss the facility itself. This pad is actually built for Falcon Heavy. Falcon Heavy, for those who don't know, is our heavy lift launch vehicle. It's 3 of the first stages that we're sending up today, essentially strapped side by side. This allows us to carry more mass to space. So that's one difference than the launch site out at Cape Canaveral, is this one is designed for the infrastructure for Falcon Heavy. Similar function, just a little bit beefier. Now, why do we have one on the East Coast, and why do we have a launch site on the West Coast? As Tom mentioned earlier, you need access to where you want to go in space. You need direct line of sight to the orbit that you want to get to. But with that in mind, the selection is typically dictated by the path that gets you there with the minimum amount of time over inhabited areas. You want to fly over oceans instead of people. So if you're going west or if you're going south, like we are today, you want to go out of the West Coast. If you're flying east or you're flying north, you want to fly out of Florida so that you're going over the Atlantic Ocean instead of the East Coast itself. So that's why we have 2 separate launch sites. Now, just like at Cape Canaveral, where we had the landing for the last flight, we have a landing zone here at Vandenberg, but for today's mission, we're going to be doing the proof of concept to attempt the landing again on the drone ship. This drone ship is dubbed Just Read the Instructions, and it is currently stationed keeping a little bit under 200 miles west of San Diego. Now, landing on a drone ship is slightly different than landing on a landing zone because it takes less fuel to get all the way back. The U-turn is less drastic, and you don't have to go as far because you can jump off in the ocean just before you get back. So because of that, you can use the extra fuel to send a payload higher or to send it faster into orbit, and that's exactly what we're doing here today. That maneuver is about 300 gigajoules, which is about the same energy it takes to power San Francisco in 5 minutes. To learn more about this topic, I got the chance earlier this week to talk with an expert in the field.
I'm standing here on the surface of Just Read the Instructions, one of our 2 autonomous spaceport drone ships that will host the vehicle as it re-enters the atmosphere and lands on the surface. I'm here with Frank Tybor, Senior Manager of Launch Development. Frank, tell us a little bit about this vehicle and what you do here.
Our mission is to go out and provide a landing surface in the middle of the ocean for the Falcon 9 rocket.
So we have drone ships, and then we have the landing zone that the previous flight actually landed on. What's the difference between the attempt to land on a zone versus land on the drone ship out in the middle of the ocean?
So it really depends on the mission. To get back to a landing pad, you have to burn propellant. So, if we're going to what would be a geosynchronous mission, satellites that need a much higher energy orbital insertion, we can go where the rocket's going.
Gotcha.
That's where this really becomes useful.
The ultimate goal is to eventually land back at Vandenberg in the same way that we land at Cape Canaveral, but we're still going to demonstrate the next few missions on the drone ship. Is that correct?
That is correct. So we've started basically fabricating the landing zone 2 at Vandenberg Air Force Base, and we're really excited to use it.
So this is one of 2 drone ships that we have. This one is here located off the west coast. The other one is in the east coast in Florida, correct?
Yeah, so our other drone ship, Of Course I Still Love You, is in Port Canaveral right now, Florida, and that's to support all our missions out of the Cape.
Walk us through some of the timeline about what happens on the drone ship in the hours that precede T-0 liftoff, and then what happens just before it lands.
So from the drone ship, we'll get on station about 8 hours ahead of time. That's enough for the crew to board, basically check all the systems and prepare it for a landing. And then the crew will get on board a separate vessel and go about 10 miles away and wait for the booster to come.
Okay.
And then about 10 minutes after liftoff, we'll be doing a landing attempt.
Say we land successfully. In the moments after touchdown, what happens?
The rocket basically begins an automatic program safing sequence. So at that point, the rocket's sitting here, our crew is coming from their staging point, getting ready to get on board. And then once we come in, we'll bring a crane, we'll lift the rocket vertically, and then break it over on the dock, and it becomes its own semi-trailer. So we put little wheels on the back of it, and then we'll tow it to Vandenberg for inspections.
It's pretty surreal standing here on the surface just next to where the rocket is going to have gone to space and then land, touchdown right next to us. This team does a pretty crazy thing.
We have an amazing job, and everyone on board is super excited.
And you and your team have built a truly fantastic vehicle here, so thank you very much.
Well, thank you.
We are in the final few minutes before we're about to lift off from Vandenberg Air Force Base with the Jason-3 spacecraft. I did mention earlier that there was a propulsion issue and the team was working. That was dealing with the Merlin vacuum engines. At this moment, though, we reviewed the data and both NASA and SpaceX concur that we are go for today's launch. Nothing to worry about, and that's going to affect our liftoff today. At this moment, you can barely see it on the screen, but the vehicle has fully pressed up. They did this about a minute or so ago, getting ready for the strongback retract, and you will actually start to see the white strongback on the right-hand side of the rocket in that image begin to pull back, and that's really the final few minutes before we're about to take off. Certainly the sweaty palms moment for me, and you can see it actually, the retraction is started, and there is motion at the forward end of the rocket. Meanwhile, the vehicle also transitioned to internal power about 2 minutes ago. That transition worked as planned, and we are ready to go. As you can see, that strongback in the forward end is moving away. It's going to tilt about 20 degrees or so and get ready for the Falcon 9 to lift off. Meanwhile, on the recovery side of things, we are dealing with 12 to 15-foot waves out of the drone ship. It's got a bit dicey out there. In this moment, though, we do think we are going to still make our attempt with the drone ship to land the Falcon 9, but it is certainly a lot more challenging to land on a moving sea platform than it is to land on a launch site, as you saw with the Orbicom mission earlier. And that weather, it does look like it's foggy there. It may make it a little bit difficult for us to see today's mission, but the ground winds are low at the launch site, as well as our upper altitude winds, so we have substantial margin for guidance through today's flight, both for structural and guidance navigation margins. Weather's going to hold out. So since everything looks like we are go for today's mission, let's check it out from Vandenberg Air Force Base, today's launch.
All right, so as you can see, the crowd is growing in anticipation here, and we're getting really excited. We're at just about the T-3 minute mark. As you saw with the drone ship video that we showed you, that's really more than just a barge. It's actually a really sophisticated piece of equipment.
So if you imagine that landing on a platform in the middle of the ocean is actually a much more difficult task than landing on a solid pad back on the ground, right? There's actually a lot of sea motion, like John was saying, the waves. So the spaceport drone ship, just read the instructions, actually needs to have a lot of systems to keep it in exactly the right spot so the rocket can come right down on top of the deck.
And it's about the size of a football field, which sounds pretty big, but whenever you are going just under Mach 6 and from 124 miles above Earth, that's actually a pretty tough target to hit.
Now remember, going into orbit is really more about going really fast sideways. So if you want to come back to a stationary drone ship, you have to cancel out all that velocity. It's a very difficult cool thing to do.
Just a note, we got confirmation that LOX load has been completed. So, landing the stage, there are 3 systems that let us do this. First one are the engine relights.
These are the same 9 Merlin engines that are about to blast it off the pad. A few of them relight several times to slow the first stage down as it comes back to the atmosphere and towards the drone ship.
Right. Next one are the grid fins. These are what you might identify as looking like waffle fries on the side of the rocket, and they allow us to actually steer the rocket itself.
They pop up and use air resistance to guide the first stage right back to the drone ship in the ocean.
And lastly, the landing legs. So these are what pop out just before the first stage reaches the platform itself.
So we're actually getting pretty close to the launch. So we're going to take it easy right now and listen into the last few minutes before the Falcon 9 lifts off the pad.
Ground report vehicle gas supplies are isolated.
Vehicle gas supplies are isolated.
The vehicle's back in manual.
Good self-align.
VC, report flight software state changes. Wilco.
Vehicle's in auto idle. Vehicle's in startup.
Rock, confirm range is green.
Rock, range green.
T-minus 30 seconds. T-minus 20 seconds. T-minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 0.
Stage 1 ascent burn.
Lift off of the Falcon 9. GC moved to section 57, post-launch pad operations to secure on net A.
GC to section 57, post-launch operations.
First stage propulsion nominal.
Vehicle is pitching downrange.
First stage PU is active.
Copy that. Ending pad aboard auto.
F9 power nominal.
And the Falcon
F9
9
telemetry
has
nominal.
cleared the launch pad at Vandenberg Air Force Base, delivering the Jason-3 spacecraft to a circular orbit about 1,300 kilometers away.
Full altitude is 6.5 kilometers. Velocity is 280 meters per second. Downrange distance 1.1 kilometers.
And the vehicle is just transitioning into the supersonic regime. It's going faster than the speed of sound right now, and shortly we're going to reach max Q, or the maximum aerodynamic pressure. It's one of the highest stressed states on the rocket.
First stage propulsion remains nominal.
This burn will last for about another minute or so.
Falcon 9 power and telemetry nominal.
Cutoff, followed by our stage separation.
And vac chill has started.
They have begun chilling in the Merlin vacuum engine, flowing liquid oxygen through it, and that is actually a view from the thermal imager on the left side of the second stage.
Vehicle is supersonic. Vehicle has reached maximum aerodynamic
All right,
pressure.
so we had a great liftoff of Falcon 9 from Vandenberg Air Force Base.
So we actually have 3 really rapid events coming up right now. First is the stage separation, then is the relight, or the first burn of the second stage of the rocket, and then right after that, the fairing deploy. These are
Vehicle's
really
on a nominal
rapid in
trajectory.
sequence, so we're just going to watch and see what happens here.
So while we're
Altitude
waiting for those to happen, let's talk a little bit about the orbital mechanics that we're going to be doing today. So for those of you that follow our launches on a regular basis, we typically launch our rockets from Cape Canaveral, and like we said before, we launch from Vandenberg Air Force Base. successful main engine cutoff.
As you can hear, the crowd's very excited. This is a fantastic milestone.
Booster has been deployed. We have visual confirmation of stage separation.
As you can see on your screen right now, the MVAC engine has started up on the second stage, and it's on its way to our parking orbit before we get to polar.
So the two views that you have on your camera there, the one that you see right now, or just had there, that's our infrared camera. That'll show shades of gray to display where the thermal dispersion is across the bell of the second stage.
And then the other view is a visual camera. Oh, we're actually looking at the fairing deploy right now.
All right, so we're just waiting for fairing to deploy.
And we have successful fairing deployment. That's fantastic.
All right, that's great. These are all really important steps. This view that you see here, so that is second stage pulling away from planet Earth. This is one of my personal favorites that we get to see. You
can see that MVAC engine bell glowing hot with the exhaust gases. It means we're headed exactly where we need to be.
Okay, so back to the orbital dynamics for today. So the polar orbit that we're trying to achieve today is actually pretty important.
So normally when we launch geosynchronous or low Earth orbit missions to the International Space Station, we're usually taking an orbit that's pretty close to the equator around the Earth.
Let me give you an Earth.
Thank you. So typically we're going around the Earth in this direction. However, for a science mission like Jason-3, polar orbits are really important, and that's an orbit that goes the opposite direction on the Earth, so you pass over both the north and south poles. This is really important for science missions.
Just like Jason-3, so like we said before, it's going to be measuring global sea levels, and it'll be doing this once every 10 days. So that snapshot that we get of planet Earth as it goes from North Pole to South Pole is really important and perfect for the job that Jason-3 has to do.
Now, to get there, there's actually two separate burns you need to do. The first burn is what we're doing right now, and then there's actually a 45-minute coast period between the first burn and the second burn. That second burn will circularize the orbit to a final polar orbit and get it exactly where it needs to be for its science mission.
Yeah, so we're really excited. We had some great events today. Again, the view that you're seeing on your screen right now, that is the second stage as it is taking Jason-3 to polar orbit.
So in just a few minutes here, as soon as we get confirmation that the first stage is coming back towards the drone ship, we'll be looking at the second stage one final time and then taking a 45-minute break before the second burn and satellite deployment.
Yeah, exactly. So just to recap everything that's happened, we had successful stage separation. We're waiting for the first stage booster to come back. We're going to be testing out landing on our autonomous spaceport drone ship, although, like John said earlier, we're experiencing some pretty heavy waves out there. All right, so like we said before, we've had a really successful launch so far today. We're actually going to be sending it back up to John for a quick status update. Be sure to keep following along.
So far, we are on a nominal trajectory with that second stage performance. We are about 4 minutes away from the second engine cutoff, where we are going to park in our orbit and then get ready to deploy the Jason-3 spacecraft 45 minutes later after we do that circularization maneuver we talked about earlier. Meanwhile, the first stage has performed a successful flip, and it is on its way back to the drone ship. We'll know shortly how we're doing in the burns. The boost back burn has been conducted, and that was successful as well. You can see the image from the drone ship. We have the fire hoses there for some water suppression on entry as we are preparing ourselves for the touchdown in about 3 minutes or so. So at the moment, everything is proceeding nominally on today's mission. I'm going to keep my eye on the data here right now while you guys get the opportunity to keep watching this mission carry through.
So let's talk a little bit more about the systems that take the first stage back down towards the autonomous spaceport drone ship. Like John was saying, there's actually several different burns that are happening right now. There's 3 separate MVAC or Merlin 9 burns that the first stage does.
Yeah. So the first one we've already done, like John said. We've actually flipped the booster around and we're bringing it back into the right place, lining it up with the drone ship.
That's called the boost back burn, naturally.
Yeah. We're waiting for confirmation of the second burn, and that's what actually will slow the first stage down so that it doesn't burn up as it re-enters the atmosphere.
We call this one the re-entry burn, again, for obvious reasons.
Yeah.
So when the booster's coming back at that point, it's coming back extremely fast, and if it's slammed in the atmosphere, it would not be good for the engines and systems. So we need to slow it down just a little bit so it's ready to enter the atmosphere without damage.
And then the third and final burn is what we'll be able to see. Okay. So the cheering that you see has been confirmation of the boost back burn has begun.
So it sounds like we're on our way back towards the drone ship, which is a fantastic milestone. Just got 2 more burns to go, and we'll be back in the drone ship.
I have to say, the energy here is palpable. Like, everybody's just so excited to see what happens. And just to reemphasize, this is a test that we're doing today, regardless of if we land successfully or not. We're going to get some really important data from the landing attempt today.
That's the most important. Even if there's a little bit of fire, it's not a big deal. This is exactly what we try to do. We learn from everything at SpaceX, whether it's a success or a failure. So
keep in mind that nobody is actually aboard the drone ship, and it's 200 miles away, so everybody is perfectly safe.
Now, just like the last launch was a night launch, so the landing berm was actually very visible, as you could see, coming down for the last 100 feet above the pad. This one, it's still a little foggy in the drone ship, so I'm not sure if we're going to see it exactly perfectly, but you definitely will be able to see the rocket coming down towards it.
And like you see on the right side of your screen there, that is a live shot of Just Read the Instructions as it's waiting for Falcon to return. We're at just under 30 seconds at this moment in time.
So the Just Read the Instructions is actually the same drone ship that we've used before, just now it's on the west coast instead of the east coast.
Yeah, and then the thing that we're all waiting to see is the landing legs. So these are the 4 landing legs that will deploy from the side of the rocket so that the engine can, so that the rocket can set down and land safely without damaging the bells.
And these landing legs have a pretty big span, so it's actually really important that it comes exactly right down where we expect it to be, which means that the drone ship also needs to be exactly where the rocket thinks it's going to be.
Yeah.
So it has thrusters to make sure.
Okay.
Looks like we're just about to see the first stage coming towards the drone ship on your screen sometime soon.
It's so quiet here right now. Everybody's waiting in great anticipation.
You can see the extinguishing system on the drone ship right there. Hopefully in just a few seconds you'll be able to see the re-entry burn as the rocket approaches the drone ship.
Stage 1 landing legs have deployed.
Seco 1.
Landing legs have deployed. Looks like we should be seeing it soon.
Landing legs have deployed.
And stage 2.
We've also had confirmation that we've had a successful cutoff of our second engine, so it's now entering the coast phase. Again, just waiting for Falcon 9 to set down here on our autonomous spaceport drone ship.
Looks like we might have a little bit of a problem with the video, but we are waiting to hear exactly what's happening.
Just a reminder, this is 200 miles away. There's no Wi-Fi, unfortunately.
So it's unlike the pad shot we had the last landing. We may need to wait just a little bit to get confirmation of whether the landing was successful or not. But like I said, just to test, the primary mission is to get the Jason-3 satellite into its polar orbit, and that's what we're really all here for. It sounds like we just got confirmation that the parking orbit for the Jason-3 satellite in the second stage is good, which is fantastic. That means that we're on our way to our final polar orbit insertion. Which, like we said before, that's going to be about 820 miles away from Earth. Also the distance from New York City to Atlanta. So like we said earlier, we actually have a 45-minute coast period between the second stage's first burn and second burn. Now, during this 45-minute coast period, we're not going to be here with you. We're going to be showing you a graphic that displays telemetry from the rocket so you can see exactly what the second stage is doing. And after the 45-minute window, we'll come back and guide you through the final burn and then also through the spacecraft separation. Right. So these are still really important milestones. So we do hope you stay with us to watch as we have the final confirmation of payload deployment. And we don't have any information right now about the drone ship and the status of the first stage, but hopefully we'll get some of that really soon. We lost satellite signal to the connection of the drone ship, but this is pretty normal during rough seas. It's a satellite link. It needs precise pointing, so it's not necessarily a bad thing. As soon as we have some information on that, we'll bring it to you, and hopefully it's a good land. Unfortunately, just one of those days. We don't always have perfect weather here in Southern California. However, we're dealing with it as we can. So now, once we go through we're about to sign off briefly for our 45-minute coast period, but we will be back. Don't go anywhere. As soon as that 45-minute coast is over, we'll be back right before the second burn, and then for the satellite separation. Okay. Be sure to follow the animation, and we'll see you soon.
We are just 25 minutes into today's mission, and a quick update on that experimental attempt at landing on the drone ship. It looks like we came in on target as we planned. As we touched down, it was a slightly harder landing than we expected, and it looks like one of the landing legs may have broken as we touched down on the drone ship. I'd like to emphasize that we are on target. We did hit our intended goal, and we are going to take a lot of data from this. Engineers are still downloading the data from the drone ship at this moment, and we will have some footage potentially to show you guys later in a few hours once we get back some aircraft footage as well as some other remote cameras, exactly how today's performance went. So unfortunately, we are not standing upright on a drone ship at the moment, but the good news here is that the primary mission is still on track. We are in that parking orbit that I mentioned earlier. You can see the animated graphic on the right-hand side of the screen there as we are going up to that 1,300-kilometer apogee mark before we ignite the second stage engine again to circularize the orbit. So since that is continuing to go nominally, we're going to go silent here again for the next 20 minutes or so until we get ready for, about 30 minutes or so actually, until we get ready for that final engine ignition. So thanks for sticking with us, and we'll be back shortly with the second engine restart as well as the payload deployment for the Jason-3 spacecraft.
Thanks for sticking with us. On the left-hand side of your screen, you can actually see the engine bell of the second stage as it's completing its orbit coast over the surface of the Earth.
Right. The bright light that you see there is actually the sun reflecting off of planet Earth. The engine itself has not actually ignited just yet.
So the second stage, second burn, is coming up in just a few seconds here. This second burn is needed to circularize the final orbit to get Jason-3 exactly where it needs to be.
Right. So we've gone through a coast period, and we are approaching the time when we're going to be reigniting the second stage to get it into its final orbit.
So the graphic on the right, the simulation you've been seeing, the telemetry simulation, it looks like it's moving pretty slow. And this is because even though we're going 17,000 miles an hour right now, the Earth is pretty big. And the orbital period for most low Earth orbit, like this orbit we're going to today, is about 90 minutes. So if you're taking a full 90 minutes to circle around the entire Earth, makes for a pretty slow-moving simulation experience. But it is actually going very fast right now. And we're about to give it another extra kick to get in exactly the orbit we want to get to. So in just a few minutes here, we're going to be igniting a second stage, and then right after the second stage, second ignition, we'll be blasting that Jason-3 satellite off of the second stage for a full, hopefully successful deployment. And that deployment signals the success of the mission. We're all crossing our fingers, hoping everything goes well for this last maneuver.
And for those of you that have perhaps just joining us right now, we did have a successful separation of our two stages. However, at this point, we lost video feed of our drone ship, so we haven't actually had visual confirmation of the status on that at the moment.
Remember, the drone ship is in the middle of the ocean with a lot of waves, a lot of sea, and the satellite link needs to be pointed directly at the satellite, so it is pretty tough to get a good connection, but hopefully we'll get some good data off of it. We do have, our engineers will take a look at everything, and honestly, you try to make an omelet, you have to break a few eggs. This type of failure is not a huge big a deal. It's the main mission is getting the Jason-3 satellite into the correct orbit.
Right, and just to reiterate, there was nobody aboard the drone ship, so even if it did end in a big, beautiful ball of fire, it's okay, and it's 200 miles away from us, so everybody was perfectly safe for this experiment.
So we will have more information for you coming up soon, hopefully. But for now, we're just going to hope that the second stage, second burn, here it goes well, and we can get this satellite into its final orbit so we can start doing some great science.
Exactly. So let's talk a little bit more about the orbital dynamics of what we just got some cheering here going on in the background.
It looks like we might. It looks like we have confirmation of the second stage ignition, second ignition. This is great news. It's going to burn for about 20 seconds. I don't think we have reliable video for it right now, but it is burning right now. We have good telemetry from the second stage. This is fantastic news.
And we've just lost signal again, we're being told, unfortunately. Space is tough, especially whenever you're trying to show video from space. So we apologize for that, but I'm sure that we're working through this.
So as the satellite, as the spacecraft, the second stage and the spacecraft attached to it goes around the globe, it comes within range of different tracking stations. Oh, and it sounds we just have confirmation of being in a good orbit. So the second stage, second burn was successful. That's great news.
Awesome.
We're just waiting for the final confirmation of satellite deployment. And it looks, that sounds, everyone here is very excited. That means we're getting close to a fully successful mission.
Yeah. Well, like we said before, the majority of our SpaceX family is actually at Vandenberg Air Force Base, and that's the launch pad that we launched from today. So that's why you can see our crowd is maybe not as large as it was for our last launch just a month ago. However, we all want to see a rocket launch in person, so.
Yeah, there's nothing like seeing a rocket launch right there at the pad. The sound is incredible.
Exactly.
So right now we're just waiting for a final confirmation that the satellite payload has been deployed successfully. As soon as we get that confirmation, that means we're in a great spot. That means we've successfully completed today's mission.
Yeah.
So keep watching this telemetry camera on your screen right here. This is accurate. It's moving kind of slowly, but this is the actual trajectory of the spacecraft. As we get telemetry from the rocket, we can see it on the screen right there.
And we just had confirmation of a successful payload deployment, so we can say that today's mission has been a success.
This is fantastic news for everyone here. This is exactly what we go for. We want to get those. We're trying to deliver the customer payloads right to the specific orbit. This is fantastic.
As our co-host mentioned earlier, this has been a labor of love, and we're so excited to say that Jason-3 has been successfully deployed.
And glad to hear that the final launch of this configuration, the Falcon 9, was successful, just like the first one from Vandenberg back in 2013. So.
And on that note, we're actually going to send it back to Brian, who is currently live at Vandenberg Air Force Base.
Thanks so much for watching us.
Al, it was a wonderful experience watching the rocket launch live from Cabrillo High School, just outside of Vandenberg Air Force Base. What happened here today? We didn't quite read all of the instructions in the attempted landing on the drone ship, but again, landing back at the landing zone and landing on the drone ship are two crucial enablers for the next stage of recovery of boosters. So those were great data points that will be essential as we move forward and attempt again. However, it must be reminded that that is the secondary objective. The most primary mission for today was the deployment of Jason-3 into low Earth orbit. It is currently up there, healthy, in the right position, and providing extremely high resolution data about the surface of the ocean's height. This is crucial for climate change and many other factors that this entire planet is concerned with. At this point, we're going to close out our coverage. I'd like to thank our co-hosts. I'd like to thank our customer. I'd like to thank NASA, the range, and you, the viewer, for participating with us. Our next mission will be SES-9. So until we see you next time, I'd encourage you to look forward and to look up, for the stars look very different today.